Thank you, awesome. My name is David Woessner, or for my American friends, Dave Woessner. So I'm actually out of the Detroit area, but originally from Germany. I live in D.C. now. I'm the general manager at Local Motors, responsible for D.C. and Detroit. Pleasure to be here. Thank you for Congressman Ryan's office and Carnegie Mellon and America Makes for hosting this briefing. I went to Georgia Tech, so I want to note that there's other really good schools that are doing a lot of things in additive as well. So just pointed that out. So without further ado, I'll take a little bit of a different view than I think some of my fellow panelists have. I'll talk about how we've applied additive manufacturing and 3D printing in our process of direct digital manufacturing at Local Motors. For those of you who don't know who we are a technology company that designs, builds, and sells vehicles at the most fundamental level. So with that, I see a couple of people who are my age, or older, and a lot who are younger. So anybody remember this? Right? Like having to dial the 1 really sucked. Like the 9 was easy. But I say that because how many of you don't have a smartphone? Oh, wow, we have some pioneers in here. Yeah, so most of us have a smartphone. So the 100 years, we've gone a long way in how we develop and utilize and build and produce phones. Well, in our industry, the vehicle industry, in 100 years, we're pretty much still making cars the same fundamental way. From the time of Henry Ford in the early 1900s to now, it's pretty much large-scale manufacturing that's capital-intensive and has long lead times and has tremendously complex supply chains. And so that started, with Gottlieb Daimler and Karl-Heinz Benz in Germany, and progressed to the invention of the assembly line in Detroit with Henry Ford. And it's continued to be this way for the last 100 years. And fundamentally, what Jay Rogers, our founder and CEO, when he started Local Motors in 2007, 2008, he wanted to get away from that and really fundamentally change how cars are designed and built. And also sold, but others are doing that too. Tesla and Leo Motors and a number of others are looking at selling cars a different way than the traditional model. But I want to focus today on really the design and production process. Excuse me, I'm a little under the weather, so apologies. So this is the Rally Fighter, which was one of our first vehicles. Most people don't know we've been around since 2008, so we've been around almost 9 years now. And from that perspective, what this represents ultimately is really the democratization of product development and the democratization of manufacturing. Because what happens here with the Rally Fighter is those images are actually all of the people that worked on that vehicle over a 2-year period to bring it to life. And so the other part that was part of this vehicle, it's a street legal rally desert racer that we produce in Chandler, Arizona, right outside of Phoenix. And it actually is a DIY car. So people come in and actually produce it as part of a family experience over a week or 2 weekends. And so they're actually a part of the process. And then the other thing that's critical for us is we're an open company. And so every Rally Fighter actually has an open wiki. And so every Rally Fighter actually has improvements from the previous Rally Fighter. So continually it gets updated and improved. So it's continuous improvement at its truest word. So how do we make this happen? And really it's based on the platform that combines co-creation, right, which is using the power of the crowd, crowdsourcing, but harnessing the power of the crowd to ideate, design, and engineer products collaboratively and continuously improve and provide a feedback loop so that each product gets better from the previous one. And the second piece is micromanufacturing. And micromanufacturing is not large-scale manufacturing. It's really a small footprint, so believing to produce locally in low volume and to really create products that are relevant for local markets. And then the other thing that we really fundamentally think about that's different than traditional manufacturers, our community that's both online and offline. So online, it's a platform just like a Facebook or something else where people come together to collaborate. But then we also have an offline community, which is in our microfactories, which consists of labs and development spaces or maker spaces, as well as build floor and retail capability. So you can think of like Apple Tesla store meets GE Schenectady Research meets Ford Rouge plant in Detroit, all in about 50,000 square feet that can build upwards of 1,000 to 2,000, depending on the mix of vehicles annually. And then we really bring together consumers and solvers in kind of this customer 2.0 environment that we want to engage them in actually making the products that are locally relevant to their communities. What this means, what some of our panelists already alluded to, is we commercialize faster and at less cost. So you'll see the number of days, the total capital investment, and the number of people. So we go to market much faster, and this, by the way, is comparing us to the Chevy Volt, the Tesla Model S, and the Fisker Karma, and this was the Rally Fighter, based on our number to get to the first 25 vehicles produced. And so you see it's a lot faster, a lot less capital intensive, but includes a lot more people in the development process. And so what you can see here, and it's from a Tesla perspective, and Tesla now, the Model S is crash tested and it's FMVSS certified. So I know we talked about FAA and some other organizations. From our perspective, it's the FTC from a distribution perspective, and it's also the NHTSA and NCAP and FMVSS that from our regulatory perspective, and the EPA that control whether we are actually producing a street legal vehicle. So our vehicles, and the one that's somewhere in the vicinity of this building, and that you can see once we leave this panel, is not highway legal yet. It's not street certified, not highway certified, but our process is leading to us towards that, towards the end of this year, beginning of next year. But you can see clearly we continue to reduce the time to market. We had the design for the swim in July of 2015, and we had the first prototype operational and working by September 8th. So that's a pretty fast process, and that's all enabled by the fact that we are really essentially a toolless car maker, right? We don't need tooling to go and have sheet metal pressed, right? Which that tooling alone takes probably 16 to 18 months to design and another 16 to 18 months to install. Our tooling is a big area additive manufacturing printer that there exist 4 currently in the world. We own 3 of them. So we're doing a lot of work that's brand new on the tooling side, as well as on the production side, on the material side. Software, as you alluded to, combines it all. And it's really about the digitization of manufacturing. Can you play that? I think there's a, yeah. It's actually embedded. Oh. Oh, that's the PDF. Yes, scroll down. So that's a time-lapse video, which you'll see if we can get it going. Perfect. Of the first 3D printed car in the world being printed at IMTS. This process is about, it's not showing up. So it's printing. You would see it. It's a time-lapse video of the first 3D printed car, the Strati, which was printed in September of 2014 at IMTS. It's a total process of about 44 hours.
Say hello to Veritas.
Don't worry about it. Just
The
go back to the
simple,
presentation.
height-adjustable.
You can Google it,
Solution.
www.youtube.com, and type in locomotive striving. There you go. But as Christine mentioned, it's, we're layering. So direct digital manufacturing is, right, it's really for us, it's a process of additive and then subtractive, and then there's the assembly part. So it's actually a three-step process. And what you'll see when you look at the car, there's aspects of the car that come directly out the printer that aren't finished, and then there's pieces that are milled, and then there's actually pieces that are wrapped. So you can see the different levels of finish. Thank you. So the next slide, we'll talk about simplification. How many average components are in today's vehicles? Yes, anybody. Don't be shy. 10,000. How many? No, not a million. 10,000, you're off by about a factor of 2. So right now, in today's car, with actually the powertrain being mostly the most complex, it's between 20 and 25,000 components. That's the number of components we have in the Strati. It's 50. In the Swim, there's probably 75. We think the highway certified car will be less than 100. So now you're talking about a reduction of complexity in your supply chain, which will really enable people to design locally relevant vehicles again, because they can source locally made components. So then this was the LM3D series, which we unveiled at SEMA in November of last year, which is somewhere around this vicinity. But the part is the configuration. So on the left-hand side, right, it's the same skateboard. There's a different body panel. So the left-hand side is the Swim. The right-hand side is the Sport. In the future, we will have another additional configurations. We think 8 to 10. I think ultimately when you get to the level 5 of customization, we will be able to, if you can design up to a set of standards and requirements that meet FMVSS and safety targets, then technically you could design your own vehicle and send it to us and print it. So talking about the ability to customize. The other thing, what we are really pushing is sustainability. So beyond being safe and smart and simple, we need our vehicles to be sustainable. And so we're actually working through a process that you can come bring the vehicle back to our facility. We'll tear it apart, repurpose some of the components, melt down the material which the car's printed from, which is a carbon fiber reinforced ABS plastic, and repurpose the vehicle, and we talk about upgradable hardware. So it's potentially a very highly customizable vehicle. There's another vehicle we're working on, which I can't deny or confirm, but most likely will be around the National Harbor area in the June, July timeframe. This is some of the process, and Gina, wave Gina. Gina over there has the material, which is basically the pellets that get melted, and then the additive part, the subtractive part, and then the maker bots. We're printing a Swim replica right now, so go get you a Swim replica and put it in your office. These are the 4 components or 3 components of our facilities. We have a retail space, a lab space, and assembly. Our sales and demonstration facility in the DC area is in National Harbor, which is opening later this spring. So basically, transportation ecosystems made locally, designed by the world. Thank you.